Last unit, we did all sorts of transformations, rotations, reflections, translations, and dilations. We talked about which transformations resulted in a rigid motion where all the polygons were congruent to one another and which ones did not with dilation, and that's because the size of the triangle or whatever polygon we were working with either got bigger or smaller, so they were only similar. So, this chapter, we are focusing on trying to prove two triangles being congruent with one another. Before we are able to do that, we need to get down the idea of what it means to be congruent. So, recall that when we rotated a figure, if the figure was reflected or if it simply was translated so it slid over, the size of that triangle, in this case, did not change. Okay, we still see congruency, and the tick marks help to show that, and the arcs help to show that congruency remained. The position of this polygon just happened to change. So the first thing we're going to look at is I am given two congruent triangles. Okay, triangle JKL is congruent to triangle TSR. And we want to name all corresponding parts. Well, with the triangle, a triangle has three sides, three angles. So we need to show which sides are congruent to which sides, which angles are congruent to which angles. If you have a picture like the one to the right, you're just looking for the same number of tick marks, same number of arcs. So starting with sides, I'm going to start with my one tick mark. So JK has one tick mark. TS has one tick mark. So I'm going to write down that segment JK is congruent to segment TS. I could also use my original statement. JK and TS are in the same exact position with our congruency statements. All right, KL has two tick marks. SR has two tick marks. KL is congruent to SR. I can once again use my congruency statement. KL, SR. Last, three tick marks. JL is congruent to TR. So JL is congruent to TR. This is also found in my congruency statement. J and L are the first and last. T and R are the first and last. So two different ways to match up. You can either use this congruency statement or the pictures. All right, next we're going to do the angles. All right, so one arc is L. R also has one arc. Therefore, angle L is congruent to angle R. I can use my statement because L and R are in the third position. Two arc marks. I have J and T. So angle J is congruent to angle T. Using my statement, J and T are in the first position. Three arc marks are K and S. Therefore, angle K is congruent to angle S, and they are in the middle position in my congruency statement. So using this idea of matching sides, corresponding angles, we can set up equations in algebra to solve. So I have a congruency statement that DEFG is congruent to quadrilateral SPQR. My first task is to find the value of x. So if I look to my figures, I actually have two x's. one that represents a length, one that represents an angle. Now, the issue with the angle expression is that I have both an x and a y in there. So you can't solve when you have two different variables. So I want to start off by solving my length statement, 2x minus 4. That goes along with length QR. So how do I know which side corresponds with length QR? Well, I have to go to my congruency statement. QR is the last two letters in quadrilateral SPQR. So I need to use the last two letters in the statement DEFG. Therefore, QR is congruent to FG. So now I can set up my equation. QR is congruent to FG using substitution for those lengths. And then this just becomes a simple algebraic equation. I add 4 to both sides to get 16, divide by 2 to get 8. So the value of x is 8. Now to go back and to find y, I only have one y value, and that is the angle. Before I even begin, I need to substitute in what I had just found. So this angle is 6y plus 8, since x is worth 8. So y is in an angle position. I know that because of the degree, and it is angle Q. So once again, I'm going to go over to my congruency statement. I'm going to look for angle Q, which is the third letter N. So therefore, it matches up with angle F, since it's the third letter N. So I'm going to write an equation that represents the corresponding parts. So angle Q is equal to angle F. Now that I have my algebraic equation, I solve. Subtract 8 from both sides, divide by 6, and y is equal to 10. So now we're going to prove that two triangles are congruent to each other. In order to do so, we need to know one more theorem. That is the third angles theorem. So the third angles theorem states if two angles of one triangle are congruent to two angles of another triangle, so that means angle A is congruent to D, so that's one angle. Angle B is congruent to angle E, that's the second angle. Then we are allowed to say that the third angle is congruent to each other. So therefore, C is congruent to F because that's the third angle. So let's just make sense of that. So I have two triangles down here at the bottom. We have two corresponding angles that are congruent. I know that because angle 50 has one arc mark. Therefore, on my second triangle, the one arc mark is also 50 degrees. The two arc marks on my first triangle is 100. Therefore, on my second triangle, the two arc marks are also 100 degrees. In the last section, we just reviewed that a triangle's interior angles add up to 180 degrees. So if I take 180 and I subtract 150, my last angle is 30 degrees. Well, the same is true of my other triangle. If I take 180 degrees and subtract 150, I'm left over with 30 degrees as well. Therefore, that last angle is congruent to one another. So here's the bulk of chapter 5, and that's trying to prove that two triangles are congruent to one another. In order to show that two triangles are congruent, we need to show that the three corresponding sides are congruent, as well as the three corresponding angles are congruent. Once we've done that, then we can state clearly that the two triangles are congruent to each other. So the first mission that I'm going to accomplish is showing that three sides are congruent to each other. Thankfully, in the picture, they've done a lot of the work for us. I have two corresponding sides with one tick mark, two corresponding sides with two tick marks. So I'm already done with 2 of my sides. So I can state, due to the tick marks, that AD, segment AD, is congruent to BC, as well as DC being congruent to BA. Reason is it's given. So I need to show that the third side is equal to each other. So first I need to locate the third side. And the third side for both triangles are AC. So I know that AC is congruent to AC. That's showing that AC is congruent to itself. Any value being equal to itself, any segment being equal to itself. Okay, that's an old property. That is the reflexive property. So I've accomplished task 1. I've showed that all corresponding sides are equal to one another. Now I need to show that all corresponding angles are equal to each other. So I have 1 arc mark that shows congruency and 2 arc marks that show congruency. So I have 2 angles done for me. I can't just say angle A because there's actually 2 different parts. So I have to use 3 points to show the separate angles. So I'm going to take care of my first tick mark right here. So that's angle DAC is congruent to this bottom 1 arc mark, BCA. Now the 2 arc marks, I'll start up here with this top one, angle BAC, making sure that the vertex is in the middle, is congruent to these 2 bottom arc marks, angle ACD. That is given. So I need to show the third angle. So I'm looking at angle B and angle D. So I need to show that angle B is congruent to angle D, and this is the theorem that we just went over, the third angles theorem. So I already showed that 2 angles are congruent to one another. Therefore, the third angle has to be congruent to each other due to the third angle theorem. So now that I've showed all 3 sides are congruent, all 3 angles are congruent, I can make my final statement that triangle ACD is congruent to triangle CAB, and that is because all corresponding parts are congruent.